Hello guys, in this video we are going to discuss the solution of the problem aggressive cows. So let us look at the problem statement. The problem statement says you are given an array with unique elements of stalls which denote the position of a stall. You are also given an integer k which denotes the number of aggressive cows. Your task is to assign stalls to k cows such that minimum distance between any two of them is maximum possible. So for instance, if this is the stalls array which is given to us and k is equals to 3, then the minimum distance between cows in this case is 3, and that is why we are returning 3. And the way we are coming to this 3 is we can place the first cow at stall 0, which is at first location, and we can place the second cow at stalls 2, which is at fourth location, and the third cow can be placed at stalls 3, which is at 8th location. So as we can see, the cows are placed over here 1, 4 and 8, and the minimum distance between this will be given by 4 minus 1, which is equals to 3, and that is what we are returning over here. So that's the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is to use binary search. Let us see how we will be able to use binary search to solve this problem. So the first thing which we are going to do is we are going to compute the minimum distance between two cows. The minimum distance between two cows could be 1, because of which we are going to initialize our low equals to 1. Then we are going to compute the maximum distance between two cows. Well, the maximum distance between two cows will be given by the difference between the furthest cows. So high is equals to the difference between the furthest cows. And once we have initialized our low and high variable, all we have to do is we need to compute our mid. Mid will be given by low plus high minus low by 2. And we are going to check if it is possible to arrange the cows such that the minimum distance between them is mid. So essentially over here what we are going to do is we are going to place first cow at 0th location, then the second cow at mid location, third cow at mid plus 2 mid location, and so on. And we are going to check whether it is possible to arrange the cows in this way or not. If it is possible to arrange the cows in this way, then for now answer is equals to mid, and then we are going to check if it is possible to increase this distance. So what do we mean by this is, for now we know if we place cow at mid distance apart, we will be able to arrange all the cows. Is it possible to increase that mid distance? To do so, what we are going to do is we are going to set our low is equals to mid plus 1. So what will happen over here is low becomes mid plus 1 and high will be at its original position. Then again we are going to compute our mid, and this mid will be greater than the mid which we have computed over here, because the low was 1 over here. We will discuss more about it when we will take an example, but for now let us proceed forward. And let us say if it is not possible to arrange the cows at mid distance apart, and in which case this will be no. In such case we would like to reduce the distance between the cows, and to reduce the distance we are going to set our high is equals to mid minus 1. So that's the general idea behind solving this problem, folks. Now let us take an example to understand this. So let us say this is the stalls array which is given to us, and the value of k is equals to 3. So for this, the first thing which we are going to do is we are going to sort the stalls array. So let us sort the stalls array. So after sorting, the stalls array looks something like this. And after sorting stalls array, we are going to initialize our low and high variables. So low will be equals to 1, which is the minimum distance between two cows, and high will be equals to the difference between the furthest cows. And that difference will be given by the difference between the first and the last element. So in this case, this will be given by 9 minus 1, which is equals to 8. Then we are going to compute mid. Mid will be given by low plus high minus low by 2. So 8 minus low by 2. So in this case, mid will be equals to 1 plus 3, which is equals to 4. So this mid is equals to 4 simply means we are placing cows at 4 distance apart. So now let us put cows at 4 distance apart in this stall array and see if we are able to arrange all the cows or not. So over here, the stalls array which we have is 1, 2, 4, 8 and 9. The first cow we are going to put it at the starting position. So we have placed the first cow over here. Now the second cow can be placed only at 4 distance apart. So which simply means this can be placed as 1 plus 4, which is equals to 5th. So for that reason, we will be able to put the second cow at this position. So far we have placed 2 cows and we are left with 1 cow since k is equals to 3. Now is it possible to place the third cow over here? Well, it is not possible. So the answer to our question whether it is possible to arrange cows when we are keeping cows mid distance apart is no. In such case, we are going to reduce the distance between the cows. And to reduce the distance between the cows, we are going to set our high is equals to mid minus 1. So for the next iteration, low is equals to 1 and high is equals to mid minus 1, which is equals to 3. And folks, the reason why we are setting high is equals to mid minus 1 is because we want to reduce the distance. And now if you compute mid, which will be given by 1 plus 3 minus 1 by 2, which will be equals to 2. So as you can see, the distance gets reduced over here. Again, we are going to check whether it is possible to place the cows at 2 distance apart. So the stalls array which we have is this 1, 2, 4, 8 and 9. Over here we are supposed to put cows at 2 distance apart. So the first cow we can put it at this position, which is the starting position. The second cow can be placed at 1 plus 2, which is equals to third position. So which will be this over here. And the third cow can be placed at 4 plus 2, which is equals to 6th position, which is this position. So with mid is equals to 2, we are able to place all the 3 cows. So for that reason, we are going to set our answer is equals to 2 and we are going to check is it possible to increase this distance from 2 or not. So for that, what we are going to do is we are going to update our low and we are going to set low is equals to mid plus 1. So mid plus 1 will be equals to 3 and high is also equals to 3. Then we are going to compute mid, which will be equals to 3 plus 3 minus 3 divided by 2. So mid in this case will be equals to 3. And now we are going to check is it possible to arrange cows at 3 distance apart or not. So for that, this is the stall array which we have 1, 2, 4, 8 and 9. Now let us arrange cows at 3 distance apart. So over here we can place the first cow over here. The second cow can be placed at 3 distance apart, which is equals to 1 plus 3, which is equals to 4. So we can place the second cow over here. And then where can we place our third cow? Well, the third cow can be placed at 4 plus 3 distance apart, which will be equals to 7. So we can place our third cow at this position, and as we can see, we are able to place cows at 3 distance apart, because of which we are going to update our answer to 3. And then we are going to check whether it is possible to increase the distance between the cows from 3 or not. In which case we are going to set our low is equals to mid plus 1. So if we set low is equals to mid plus 1, then low becomes equals to 4 and high is equals to 3. And over here at this case, our binary search loop will break and we are going to return 3 as our answer. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to arrange k aggressive cows in stalls. For this, the first thing which we are going to do is we are going to sort the stalls array. So let us sort the stalls array and then we are going to initialize our low and high variable. So low will be given by 1 and high will be given by the difference between the first and last element. So last element will be given by stalls len of stalls minus 1 minus stalls 0. And then let's have answer equals to 0. Now the binary search logic, while low is less than or equals to high, the first thing which we are going to do is we are going to compute mid. Mid will be given by low plus high minus low divided by 2. Then we are going to check if it is possible to arrange cows at mid distance apart or not. So for that, let us say we have a check function where we are passing stalls array, the number of cows and the distance apart, so mid distance apart. If it is possible to place cows at mid distance apart, then our objective is to check if it is possible to increase this mid distance. So for that, low will be set by low equals to mid plus 1, and our answer for now will be equals to mid. Otherwise, if it is not possible to arrange cows at mid distance apart, in such case we are going to set our high is equals to mid minus 1, which simply means we are trying to reduce the distance, and towards the end we just have to return answer. So that's the aggressive cows function. Now let us look at this check function as well. So for check function, stalls is given to us, the number of cows is given to us, and what is the distance we are keeping them apart. So these three information is given to us. So for this, what we are going to do is we are going to place the first cow at the 0th position. So previous is equals to stalls of 0, and then we are going to set count is equals to 1, since we have already placed one cow at the starting position. And then we are going to iterate on the rest of the array. So for that, I in range of 1 to len of stalls. Please note folks, over here I am starting my range from 1 because I have already placed the first cow at 0th position. Then we are going to check if the distance between the current cow and the previous cow is greater than or equals to distance. If this is the case, then that simply means these cows are distance apart, because of which we will be able to place our second cow. So for this, count we are going to increase by 1, and previous we are going to update to stalls of I. So let me explain this part folks. This condition essentially ensures whether the current cow is distance apart from the previous cow or not. If that is the case, then at this position we can place the second cow, because of which we are increasing our count by 1. And now since we have placed our current cow to this position, so previous becomes equals to stalls of I. And towards the end, all we have to do is we just have to check whether count is greater than or equals to k, which simply means whether we were able to place all the cows or not. If we are able to place all the cows, then in that case we are going to return true. Otherwise, we are going to return false. So that's the pseudocode folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. Over here, aggressive cow is the main function. First we have sorted the array, then low is equals to 1 and high is equals to the difference between the first and last cow. Answer is equals to 0. Then the binary search logic. While low is less than or equals to high, we are computing mid, and we are checking whether it is possible to place cow mid distance apart or not. If it is possible to place cows at mid distance apart, then answer is equals to mid and low is equals to mid plus 1. Otherwise, high is equals to mid minus 1, and towards the end we are returning answer. And in the check function, count is equals to 1 and previous is equals to stalls of 0. Then we are iterating on the rest of the elements of the array, and then we are checking whether the cows are distance apart or not. If they are distance apart, then we are updating our count by 1 and previous is equals to stalls of I. And towards the end, we are checking whether count is greater than or equals to k. So that's the Python implementation folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same folks. First we are sorting the array, then we are setting our low and high, and we are getting into binary search logic. The first thing which we are doing is we are computing mid, and we are checking whether it is possible to place cows at mid distance apart or not. If it is possible, then answer is equals to mid, and we are setting L equals to mid plus 1. Otherwise, H equals to mid minus 1. And towards the end, we are returning answer. And in the check function, previous is equals to stalls of 0, count equals to 1, and then we are iterating on the rest of the element. If the cows are distance apart, then we are increasing our count by 1 and previous equals to stalls of I. And towards the end, we are returning if count is greater than or equals to k. So that's the C++ implementation folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.